Hi, I'm Greg Bonaguide with Rohde Schwarz, and here we're showing off at the IMS 2015 show our 5G offerings. And I've got a couple demonstrations here. The first one shows automotive radar at 77 gigahertz. And on the left we have our Rohde Schwarz SMW signal generator, a vector signal generator. And it's generating a 160 megahertz wide chirp that's being multiplied through this millimeter wave multiplier and coming out at 77 gigahertz. Because it's being multiplied, the chirp is also being expanded, coming out at 960 megahertz. And over on the DMOD side, we have our FSW vector signal analyzer. That's operating up to 67 gigahertz. But because we're at 77, we're actually coming in through a millimeter wave mixer and down converting to the 2 gigahertz range through the FSW. At 2 gigahertz, we have a very nice equalized 2 gigahertz output on the back of the instrument. That's also about 2 gigahertz wide. That signal's coming around into the front of this RTO oscilloscope. So the analog signal coming into the oscilloscope is being digitized by our high-speed A to D in the oscilloscope. And then we have digitized IQ samples being routed back into the analyzer for the pulse demodulation and display down here. So that's one side of the high-frequency millimeter wave offerings. On the other side over here, we have a setup for 802.11 AD. And in this case, we're generating a 1.4 gigahertz wide QPSK signal with this ARB that's going into our 2 gigahertz wide vector modulator on our SMW signal generator. And we've got two outputs from our SMW. One is providing that IF signal at the wide QPSK signal at 2 gigahertz. The other signal is an LO that's driving this device under test, which is an integrated multiplier and mixer. And the output's coming out at 62 gigahertz. Again, we're going into an FSW signal analyzer using the same B2000 option that gives us a 2 gigahertz instantaneous bandwidth for demodulation. And on the screen you can see up here we're demodulating this QPSK signal. Now it's not super clean, about 10% or so EVM, and that's mainly because of our clock source that we're using. It's not terribly clean, but the capability exists, and we've gotten very good lab results down below 3% for this kind of a measurement at millimeter wave frequencies. So if you'd like to learn more about our 5G offerings, please go to our website, www.rohdeschwarz.com. Thank you.